We will be interpreting a hypothesis test for a proportion using a calculator. This is a two-tailed test. A national insurance company claims that 40% of adults between 45 and 55 are overweight. The doctors in one county thinks this is not accurate. They test 637 patients in their county and find that 178 of them are overweight. Perform a one proportion hypothesis test at a 5% significance level to test whether the true proportion of patients who are overweight is different than 40%. So you will have an HO. So a hypothesis test, null hypothesis will be HO. The P is equal to 0.4. And my alternative will be HA. P does not equal 0.4. Our significance level is at 0.05. So our alpha equals 0.05. Now calculating this, we're going to go to stat, over to test, down to one prop z test. We'll put in 0.4. 178 is our x. Our n is 637. Not equal to, because we're testing that it's different, and calculate. We end up with a z of negative 6.21134 and a p of 0.527. Basically, it's 0 because the e to the negative 10 means you would have to move your decimal place 10 places to the left. So because our p-value is basically 0, our p is less than our alpha. P is less than 0.05, which means that the null hypothesis is rejected. So we reject that they are equal. We reject that they are equal. And that means that the true proportion of patients who are overweight is different than 40% based on a 5% significance level.